This is Digital 2 Lab 6. This is Lab 6 using random access memory with the SN7489 chip. Circuit consists of the input being a clock pulse and a push button for manual and automatic mode, which goes into the 7415 quad 2-line to 1-line chip, which is fed into 7490 decade counter, which counts individually to go through the different addresses of the 7489, which the data inputs come from a thumb wheel with pull down resistors, and the outputs go into the 7404 inverters to 7447 7-segment display driver and the 7-segment display and the resistor pack for the current limiting resistors. When you first initialize the chip, you'll see it goes through and counts through in auto mode, showing the original garbage that's found in the chip. To enter the data in, we'll switch it into manual mode, and then we will enter the data as at the address displayed on the LEDs. So we're at 0. So I have 9. So we'll select 9 on the thumb wheel. We'll load it into the chip, and it displays 9, showing it's holding 9, and we can select another address to enter in at that location, which in this case is 3, which we also need a 9, so we do not need to change the thumb wheel, so we just enter the same 9 in, and we can select another address. As you can take note, it bounces around to a random address. It says in the lab that we could halt that by putting a debound circuit into the middle of it. However, we're not making that on a menu to choose it, we're just manually entering that in. So in this lab we don't actually do that, but we could, and we could use one of the push buttons here which has a debound circuit in it. So we finish entering all the data in. So at location 2 we have a 2. Location 7 we have an 8. Another way that you can avoid using the undebounced would be to put it into auto mode and wait until it selects the address that you need again to enter a different number. Once you have all of your addresses in, you can then switch it back into auto mode and it will cycle through them. And as you can see, it doesn't matter if you finish entering your values in, it's just holding what's at that location, which you can easily stop it at any point. Change the data and push it through again. So I'll finish entering in my data. And there we have the 7489 random access memory chip. And because random access memory is considered to be volatile, if we turn the power off and turn it back on, it initiates with the same garbage data at the first.